Okay, so let's look at how these questions can be asked. Finding a gradient of a graph and then calculate the gradient at the given point of f of x. So we can sort of think about dy over dx as my gradient function. Okay, so we can find some gradient at any particular point on my graph if I do have an x variable. Let's say I have a range that's infinity from up to down, or it can be all real numbers, so it would be an element of all real numbers. Now the first question would then be calculate the gradient at the given point of f of x. So what does this exactly mean? Well, here we have the f of x. So I wrote pretty badly, but the equation's on this side. We have the f of x is equal to 3x cubed plus 4x squared plus 3x plus 4. Now we're given where x is equal to 1. So we first need to find the gradient function. Okay? We need to find the gradient function. And how we can find the gradient function, we know the gradient function is dy over dx. So what does this mean? Well, I can derive the y function with respect to x, right? So let's do that. So I'm going to write f prime of x, okay? Which means I'm going to derive the function to the first order. Now, if you're watching this video again, you should be familiar with how to do this already. So it's going to be 9x squared plus 8x plus 3. So this would be my gradient function. So I just found my gradient function. Now all I simply do is I substitute for x and I can find the gradient at that particular point where x is equal to 1. So it's going to be 1 squared plus 8, 1 plus 3. That gives me 9 plus 8 is 17, so that gives me 20. So the gradient of this function where x is equal to 1 would be 20. Let's look at the next type of way they can ask you a question. So find the values of x tangent to the curve when the gradient is a number. Okay, well, we know now that the gradient can be calculated by finding the dy over dx, right? That's how we can find the gradient. But if the gradient is given, I can therefore say, well, dy over dx is in fact equal to 12. Okay, so let's derive this function. Let's derive it where we have, in this case, I'm going to use dy dx. So we have 4x squared, so that becomes 8x plus 3. Now, we know the gradient of the function is 12, so I can substitute dy dx with 12, and then I can solve for x. Okay, so 3 goes to the opposite side, which is then 9. So 8x, or I can simply subtract 3 on both sides. That gives me x is therefore equal to 9 over 8. Okay, so where x is 9 over 8, I have a gradient of 12. Now, sometimes they might ask you to find the coordinates. So what do we do then? Well, to find the coordinates, I can then simply take my x value and I can substitute this back into my original equation. Right, so I'm going to do that. So we're going to have the f of 9 over 8. Wow, what an awful number. Is equal to 4 9 over 8 squared plus 3 9 over 8 plus 2. So that's going to be 4 times. Let's do this one without a calculator. Oh, never mind. I'm going to jump over to a calculator. Okay, so we had 324 over 64 plus 20 plus 27 over 8 plus 2. So let's see a fraction form. Okay, so in fraction form, my answer would be 116. So in that case, it's 167 over 16. So here's my y coordinate. So now I've calculated the f of x, which I can then substitute with y. So I found my y coordinate and I found my x coordinate. Now, sometimes this question might become a little bit more tricky where, let's say we have to derive, let's say the f of x is given to us 3x cubed plus 2x squared plus 4. Okay, then we first have to find dy dx or f prime of x, where we have 9x squared plus 4x. Okay, now in this case, if the gradient is given, let's just say, for example, the gradient is given as 10. So we're going to have 9x squared plus 4x. Then we have to transfer from left to right, which then becomes 9x squared plus 4x minus 10. Now in this case, you're going to find two x values. Okay, you'll find two x values, and then you have to substitute both of those x values into your equation. Now to solve this type of equation, you can simply use the quadratic formula. Okay, b squared minus 4ac. I used a completely random example, so I'm not too sure if this one is perfect or perfect roots. They're probably not, but yeah. So then you just substitute both your x values into the equation, and then you can solve, which would then substitute. So if you find x sub 1, x sub 2, you can substitute it back into the original equation to find your two different y's. Okay, that's one of the only second ways they ask you to in this case. And then we're given one more type of question. I'm just doing the three basic ones now, since this is just the introduction to derivatives. But let's say we're given the f of x, so we're given the y function. Okay, then they say find f prime of x. Whenever you see this prime symbol, be very careful. You can see something like this, which would be an inverse. Okay, it's not a derivative. That's an inverse, but that's a separate video. So in this case, we need to calculate for f prime of x. We can do that by finding the derivative or the gradient function of the given function. So let's do it. Okay, so I'm going to subtract 1 and multiply forward. Okay, the form looks like this. A times x n minus 1. Hey! It's supposed to be an n, sorry. So n x minus 1. Or you'll be more familiar maybe with this one. It's the exact same thing. Okay, you subtract the exponents, multiply forward, subtract the exponents. So in this case, I'm going to multiply forward. That becomes 48x cubed plus subtract 1, multiply forward, 6x squared. First you multiply and then subtract. Okay, first multiply, then subtract. Sorry about that. This one's going to give me 48x plus 7. The reason I just add 7, since the derivative of x or any single variable would be 1, and the derivative, I have a full proof somewhere on the channel, the derivative of a constant or a number, in this case, is always 0. So this one you never write, the derivative of a number, and in this case you can simply just get rid of the x, and then this would be your final answer for these type of equations. Let's just quickly review. So your final answer for this equation would be, what was the question? Find the value of x tangent to the curve. So you found the value of x, so that would be your final equation. But if they say state the coordinates, the x and y coordinates, you have to substitute this back into your original equation. Okay, which I did over here. And then for these type of equations, what's this? Oh, that's just two x values. And then we had one more where they say calculate the gradient at the point. So first you want to calculate the gradient function, and then anywhere, any point, let's say you calculate the gradient function, any point you want to select where x is 1, 2, 3, 4, you can calculate this point. Okay, and that would be how you answer these type of questions when they say calculate the gradient at a given point, or what else would they say? Find the gradient of a graph, or find the gradient function. Oh, it's actually a little bit tricky, because find the gradient function could simply just mean derive the equation. Okay, so that's how we solve some basic, maybe it's not basic. Anyway, have a lovely evening.